Hey boys and girls, it's a little intro clip before we actually do the video. I'm doing this at the end of the video. I've done a lot of quick and dirty editing to to make the thing more viewable. So I'll apologize for a few things ahead of time. I'm spinning around. I'll give you an example. This is a pretty good shot here, and I would spin around and to have a bright light behind me and be totally blown out here. So I would pause, cut, and edit this so that I'm not seeing stuff like this when we get done. It's more smooth and a little bit better. I mean, you can only brighten something up so much when you have black to work with. So as a screen color, but we did pretty good. So apologies that it's not all smooth and unitextual, and I didn't have the lights on overhead and the door shut. And also, apologies if you have weak stomachs. I'm walking around a lot and jiggling the camera a lot because, well, you'll see why. Anyway, I will do this and hope you enjoy the video. Thanks. Hey gang, I'm sitting here trying to do some tests for my radio gear to see how much power that my devices pull. So I've been thinking about eventually hooking up like a simple emergency backup battery, a 12-volt battery, maybe a sealed one, and running a power inverter to do some stuff in here in the shack, and being able to run 12-volt stuff directly to my supply here that breaks all my voltage stuff out. That was a fun project to build. But here's my big power supply. And I was doing some amperage readings. This is DC, of course, that my radio pulls at different power levels. However, I want to see what it's pulling in AC mode for fun. And the back of this power supply is marked with a 6 amp fuse, so I know I'm not pulling anything more than 6 amps. But how do I check my amperage load here? I was contemplating that, and I thought, well, I have a wonderful meter that will do just that. I have my field piece meter. This is one of my field piece meters. I have two, and this one is probably not my favorite one. No, this is my favorite one. This has the hold function on it. So when I power it up and I put the amp clamp on something and I want to check the amp draw, I can hit the hold function. Let's say I want to check the amp draw of the compressor on a condenser outside on startup to see how much of a load it's pulling and if I need to add a hard start kit to make it easier on the system. So I would put that over one of the leads, one of the 240 volt leads outside, and turn this on to the amp setting, of course, and hit the hold button. And this would enable me to go to wherever I need to turn on the power, whether it's the disconnect box right there or in the house or wherever I have it shut off at. Usually I'll do the disconnect box, but sometimes that's not feasible. If it's a say it's a switch box, sometimes those switches don't like to turn back on when you turn them off. So I will power it off elsewhere. Sorry, I'm shaking the camera. The hold function is great, so that way I know what my startup amp draw is, and it gives me some good information. Well, anyway, for this project I'm not getting very far because obviously it's 110 volt and it's a one-piece cable. So what we're going to do today is perform some microsurgery on my wife's jumper that probably cost more than I should be using it for this, but she just informed me she doesn't want me chopping it up. But I can split it open down here and single out one wire, which will let me be able to pull an amp load off of it. So that's what we're going to do here. Right. After several attempts to find my my old X-Acto knife, I found this one. But in digging through some of my old stuff, I ran across something a true geek should not be without: a memory keychain. Now, you're not a true geek unless it's like a really old memory chip. and this is not super old, but this is 256K of RAM on a chip. And I had 3 or 4 of these stashed in one of my toolboxes I completely forgotten about. 256K. That was 4 of those in a computer to put 1 meg on a system, and you were rich back in the day. But of course, I remember my old computer having 16K RAM, and I was rich. But that's another time, another story. But anyway, we have it separated here. So I will pick one at random, and we will use the clamp to clamp off, and I will seal the rest of them back up in there, and we will have something to work with here so we can get an amp draw. Remember now that to go nice and slow when you're using X-Acto blades or any kind of knife, because this is very, very easy to cut your fingers wide open. I've selected the white one because it'll stand out nice and pretty and cut a bunch of black strips. What got me thinking about this a while back was I've been wanting to buy one of those little kilowatts that you see. You can plug it in the wall outlet and it gives you a digital display and keeps track of your usage and stuff. And I haven't bought one yet, but I probably will for fun later. But I was trying to come up with some idea to keep track of or measure 240 volt stuff, and this is kind of a stopgap till I can figure out what I'm going to do in the long run. But I'd like to see if there's some way I could computer interface a simple meter enable watch stuff, because I was really thinking about was trying to figure out how I could I guess I could use a kilowatt in a bypass soldered together fashion and just pick up the information off one leg, because I wanted to check my water heater. I want to see how much power my water heater is pulling, because I had bypassed the water heater with a timer delay, which I will show you real quickly now if you're interested. Doesn't matter. You're a prisoner to the video. But anyway, I had throw the pillows out of the way here. I wanted to do that and do some other stuff, so I cut a door access here to get to my water heater, and I cut in a second return vent to get to it. The air conditioner, which is on the other side of the unit over there, and I wanted to wrap up the booger. I don't think that light works a little. Oh, it does work. Okay. But I want to insulate that up, and I wanted to put, oh, the cat is very interested at the door. He's never seen before. But I put a timer control on it, and as you can see, it's on right now. And every time we lose power, I have to come back in here and dink with it. So I'm probably due to do that. But I like to pull one leg off and do some sampling to find out how much power this uses in, say, a week period with the unit bypassed, and try it again with a week with the timer delay kicked in to see if I'm actually saving any money or not. Because, you know, it's hard to tell. And they say that water heaters and air conditioners are the 2 biggest usages of electricity in the house. Lighting is not as much as you would think. I had ran across a terrific deal a number of years ago on eBay, and I bought like 100 of these CF bulbs, and they do save a significant amount of electricity in comparison, but it's not the big draw to the air conditioner and the air conditioner heating. Actually, heating uses more electricity than air conditioning when you run electric heat. But that and the water heater. So I'm really curious to figure out some sort of timer device that I can homebrew that will, not timer device, measuring device that I can maybe tack on to a little laptop I can shove in there or something and do some data collecting. But maybe you guys have seen something portable and cheap, or easy to make and cheap, that you could throw some ideas at me. But besides the kilowatt, I guess I could do 1 leg kilowatt, and that'd give us some ideas. Anyway, I'm going to plug that in, do some tests, and we'll get off to back to the project we started with. Alright, here we are, the back of the 12 volt power supply. It's 30 amp, but anyway, I failed to mention that earlier. Made by a great guy. And let's see, so we're following the cable down, and I have it plugged into the jumper cable that we made, and it's plugged into a device that kind of cleans up ripples and noise and other junk. And we will place our clamp around it here, like so, and it's just showing 0.4 or so. Now, let's reach around the back here. I can find the switch and flip that on. It has powered the radio on. I don't want the radio on yet, so let's reach over here and walk around and turn it off, because, you know, you need the extra 10 seconds video time, right? Alright, power for that is now off. We show standby mode. I have about half or less of an amp at DC. So let's see what it's pulling. No load. And this is not a switching power supply. We are pulling 0.08, which was up from 0.04. So a little bit of nothing. Alright, now let's have a little bit of fun. I'm going to fire up the 2-meter radio. I have it on a simplex frequency here. We are at 50 watts power, so at DC. W5 NIG testing. 1, 2, 3, 4, 5. W5 NIG testing. That produces, where are we at? At high power, it was 6.2 amps at DC. So let's flip around here. Let me slide the microphone through here this way. And we will pull and see what kind of AC pull with taking into account for loss of power and etc. etc. W5 NIG testing. Alright, AC 1.3 amps. AC going to the 12 volt power supply. Very good. W5 NIG testing. 1.31. So, very good. So, there's our test. 1.31 amps at AC voltage of 120 volts. Give or take. You know, if you move the clamp around a little bit. But anyway, a little field testing and entertainment for fun. And look forward to comments, questions, answers, help, etc. for our little fun project. Hope y'all are having a great holiday weekend, Labor Day weekend, and I look forward to talking to you later. Bye.